So, good day everyone. So, we're going to talk about GeoGebra, a dynamic mathematics tool exploring geometry, algebra, and more. So, we are Group 6. Table of Contents, the introduction to GeoGebra, navigating the GeoGebra interface, exploring different views in GeoGebra, constructing geometric shapes, exploring transformations, creating and analyzing function graphically, working with 3D geometry objects, and advanced features and application. So, learning objective. Upon completing this module, you will be able to understand the capabilities and application of GeoGebra, navigate the GeoGebra interface efficiently, create and manipulate geometric objects using various tools, perform geometric construction and transformations, use GeoGebra to explore algebraic concepts and functions, work with 3D geometric objects, create and share interactive GeoGebra applets, apply GeoGebra to solve mathematics problem and explore mathematical concepts. So, introduction to GeoGebra. What is GeoGebra? So, it is an open source dynamic mathematics software, combines geometry, algebra, calculus, spreadsheet, graphing, and statistics. Created by Marcus Hohenwarter in 2001 for his master's thesis. So it is free, accessible to all educational levels, and foster interactive problem solving and visualization. For this video, we would only tackle about GeoGebra Classic, as it is the full-featured version of the software. So GeoGebra offers other interface like the notes, scientific calculator, only for 3D graphics, for geometry. So you can download this GeoGebra Classic just by inputting geogebra.org/classic. So this is the menu bar and this is the toolbar. So file, edit, options, tools, window, and help. One tab stand out, this view bar. So here we have algebra, spreadsheet, CAS graphics, graphics 2, 3D graphics, construction protocol, and probability calculator. So this is already the algebra view and this is the algebra classic. As you can see, you can open multiple tabs or multiple view at the same time. Also, they are interconnected. Like, for example, I would use a point. See how I can put a point anywhere in our plane and then it would automatically be listed in our algebra view. Let's say, for example, we would like to create a circle. See? The equation of the circle would be automatically listed in the algebra view. We can create a polygon, a line, and also we can find their intersection, the intersection of a circle, polygon, and the line. So we can also find the center of a circle. See, it is the K. We can also find the angles, like just by pressing 3 points. See? Angle A. So, what I love about GeoGebra is you can just hover to the option and a prompter will be shown just like this. Ellipse. Select two foci and point an ellipse. So, circle center through a point. Select center point, then point on circle. You don't need to memorize like what does it does and then search it. No, it's already shown you what it can do. So we can also find its tangents, like this circle and this point. can also do transition or transposition, reflection. See? You can also reflect about a point, reflect about circle, rotate around point, translate and dilate from a point. Let's now tackle about a function. Let's create a function 3 plus x 5 squared here. So if you want to find the extremum or the local maximum and local minimum of your graph, just click the graph and then the extremum option, then the point will be already visible or it will be listed. As you can see, this is their coordinate. You can also find the roots. See? So this is the roots of your function. So this is where mathematics turn into visual. We can also change its color, like let's say green, and then change the name, say K, and then put caption, and it will be reflected in our graph and in our algebra. So next is the CAS view. Just close it. So CAS, or the computer algebraic system. Here you can simplify a function. You can expand. You can factor. You can substitute. You can also do derivative and integral. If you're unsure about your answer, you can go to CAS and then type in your function and then compile or compare if your answer would be the same. Because we all know that using CAS is a lot more accurate than just searching through the internet. So next would be spreadsheet. I know a lot of you have research, so I think this tab would be helpful because unlike spreadsheet, you will manually put or write the formula in the formula bar. Here, you can just type in all your data and then click the one variable analysis and then analyze. You can automatically choose what kind of graph you want. It's either histogram, bar chart, box plot. So it's a histogram. And also show statistics. It would already compile your mean, your standard deviation, your variance, your sigma, mean, Q1, median, Q3, and max. This is everything you need. Also, z-test of a mean, t-test, z-estimate of a mean, the estimate of a mean. This is a faster way for us to compute or to analyze your data. Next would be the 3D graphics. So for example, I would like to create a sphere and also a plane. You need 3 points to plot a plane. So I said points. Yeah, but line can work. See? For example, I would like to tilt the plane. As you can see, I just only touch one point and then the whole graph shifted. And also, it can automatically let you see each view, like each side, because you can just rotate it. See? So, this view is perfect for visualizing gradient, cross sections, level curves, and vector operations. So now I hope you understand the different purpose of different views. Now we're going to solve some practice problem using GeoGebra. So, practice exercise. Find the distance between AB, point A63, and point B, 4, -4. Number 2. Plot A, -8 and 5, and plot B, 6, -3. What is the slope of the line AB? And 3. What are the length of segments AB, BC, and CA, where A is 2, 1, B is 5 and 3, and C is 7 and 4. Put it back to 2D, or graphics. As you can see, graphics and graphics 2, they are pretty much the same. It was good for comparing two functions. So let's type the problem. Find the distance between AB. So, point 6 and 3. So we already have 2 points. So the question is, we want to find the distance. It has distance or length. So you can just click the 2 points and then it automatically tells you that AB is equals to 7.28. You can hide it just by clicking this circle. See? It was already hidden in your graphics view. The question number 2, -8 and 5 for point A, and -3 our B. What is the slope of a line? As you can see, you can also find the slope just by clicking the slope option. So the slope would be -0.57. As you can see, either you you click the point, or you click the other point, or you click the line, it would give you the same answer as long as you press slope as the option. So, for the question number 3, what is the length of a segment? So, you need a segment, which will be 2, 1. 5 and 3, 7 and 4. So segment so again we're going to distance or length. So you can see C to A would be 5.83. That is its length. So how about constructing a equilateral triangle? Can I ask you what is a equilateral triangle? That's right. It's a triangle that has 3 equal sides. So how can we graph that in our GeoGebra? Well, it's easy. You can just click a point and then another point, then circle with circle through a point. So let's say A as our circle to B, and then B as our circle to A. We just need to create a segment from A to B and then find the intersection of the two circles just by pressing the intersect, and then create a segment that would connect B and C and A and C. As you can see, this is a equilateral. You can also do that at the D. So we have two equilateral triangles. If you want to just show the triangle, you can just hide this circle. So we have more practice exercise, like translate triangle ABC with vertices A 1, 2, point B 4, 2, and C 3 and 5 by the vector defined from point P 0 and 0 to point Q 2 and 3. What are the coordinates of the translated triangle? So problem number 2. Given triangle ABC with vertices A 2 and 1, B 4 and 2, and C 3 and 4, rotate the triangle 90 degrees clockwise around point B, which is 4 and 2. So given the triangle PQR with vertices P 1, 2, Q 4, 5, and R 6 and 2, dilate the triangle with the center of dilation at point P and scale factor 3. Find the coordinates of the image triangle P prime, Q prime, and R prime. So let's do that in the GeoGebra. So question number 1, translate ABC with point A, 1, 2, point B, 2, point C, 3 and 5. Connect it using the polygon tool. And then by the vector of point P, so translate by vector point P, which is 0, 0, 0, 0, and so this translated to this. See? Now the new coordinates of the translated triangle would be this A prime, B prime, and C prime, which was already highlighted in your algebra view. So you can also see the U, or the vector, which is -2 and -3. So for the question number 2, given a triangle ABC with the point 1, 2, 1, 4, 2, and 3, 4. I can connect it with the polygon because it says it is a triangle. Rotate the triangle 90 degrees clockwise. So we can rotate it through a point. 4 and 2 would be our point. 90 degrees clockwise. So, okay. See? So this is our new image. So this is the new coordinates. So A prime, B prime, and C prime. For question number 3, triangle PQR, which have the coordinates of 1, 2, 4, 5, 6, and 2. So dilate it. First, make it as a triangle. Then dilate using dilate from a point. So earlier, the problem says the point P, which is, in our case, it is the 1, 2. We can change the name if you want to. Put it as P. We can rename it as R, Q, and then 4, 5 would be C. And it says to dilate it to the point P. So the factor would be 3. Let's zoom it out. So this would be the new coordinate, P prime, Q prime, and R prime. So this is all about translation. So another practice exercise. Create a sphere with radius 3 units and find its volume. And number 2, create a cone with radius is equal to 2 and height is equal to 5 units. So find its volume. We're talking about sphere and cone, so what do you think a view we should use? That's right. We can use the 3D graphics. So we can just type in sphere. And as you can see, we have point, radius, or point, point. So according to our problem, we are given a point and a radius. So our point would be our choice. So, for example, we have a point 3 and 2. Oh, wait. Our problem talks about spheres and cones. So let me ask you, what view should we open to answer the following questions? That's right. We should open the 3D graphics. So, if we enter or input our equation, input bar, we can just say sphere. And as you can see, we have a option that says point and radius. Since at the problem, the problem didn't specify the point, we can just say that it is in the origin. Like that's the default. So let's say 0, 0, 0, and our radius would be 3. So this is our circle. And to find its volume, we can just type in volume, and then the letter of our equation, in our case it is A, then enter. As you can see, 113.1 will be our volume. How about the second problem, which talk about cone? You can also search cone, and then point radius. Since again, it didn't specify the other point or the center, it would be 0, 0. The other point would be the height, 5. The radius would be 2. See? So this is our cone. And again, with a similar process, we can write volume and then input the name of our cone, which is C, and enter. So 20.92 would be the volume. So another practice problem, given the function f of x is equals to 3x squared minus 4x plus 1. So find the derivative f of x and determine the slope of the tangent line at x is equals to 2. And for the second question, calculate the definite integral of f of x from x is equals to 1 to x is equals to 3. So again, with the control A, erase everything. We can go back to the graphics 2D. So we should input our function. 3x squared minus 4x plus 1. Let's derive the following equation. So we can just type in derivative and then the first option, which was the function, and we don't need to write the whole equation. We can just put the name of the function, which is in our case f, then enter. So here the f prime of x is equals to 6x minus 4. And let's say the tangent would be x is equals to 2. We can just change the f prime of 2. So it would be 8. So this is the slope of our tangent. And the other is the integral. For the second question, let's integrate f of x. So we can just say integrate. Then, as we go to the third option, we can say function, start value, and then end value. So that's what we want because we have a starting point, which is the 1, and the ending point, which is x is equals to 3. So again, we don't need to write the whole function, we just need the name or the letter that corresponds to that equation, which is f, and then 1, 3, then enter. So as you can see, the definite integral is b, meaning it is 12. As we wrap up today, I hope you've seen that GeoGebra is more than just a graphing tool. It's a bridge between abstract math and visual understanding. It turns equations into pictures, steps into movement, and ideas into something you can actually explore. Whether you're tackling calculus, algebra, or geometry, GeoGebra gives you a chance to see what's happening, not just memorize it. And in a world where understanding matters more than ever, that's powerful. So as you continue your journey in mathematics and beyond, I encourage you to make technology like GeoGebra a companion, not just a calculator. Play with it, question it, let it help you think deeper and learn smarter. Thank you all for joining me today. I hope we leave not just with new knowledge, but with new curiosity and new tools.